So today we are doing properties of parallelograms. Our essential question is, how can we use properties of parallelograms to solve for missing measures? It's right here, and I'll write it down on my paper.
Good morning, warriors. Please rise.
Okay, so a parallelogram is a quadrilateral with two parallel sides. Those will either be marked or you'll be told. Remember, the triangles show that they're parallel. So the one triangle shows that these two are parallel. The double triangles show that QR and PS are parallel. The parallelogram opposite sides theorem states that if a quadrilateral is a parallelogram, then the opposite sides are congruent. So here I have QP and RS are congruent. You can see that by the one tick mark. And then I have QR and PS are parallel by the double tick mark. Then I also have the parallelogram opposite angles theorem. It states that if a quadrilateral is a parallelogram, then opposite angles are congruent. So I have this angle, Q, is congruent to angle S. I accidentally hit disconnect. And then I have angle P is congruent to angle R. So number one wants me to find the values of x and y. So if I take a look, x is a side length, and it's parallel to 12. So what I'm going to do is I'm going to take those two values and set them equal to each other. So I'm going to have x plus 4 equals 12. And then I want to go ahead and solve this one. So I would just subtract 4 on both sides, which gets me x equals 8. Then y is an angle, and it's opposite angle C. So those two are congruent. So I can set them equal to each other. And I'm just going to have y equals 65, because there's not an expression for me to solve. So number 2, x on this one is an angle, and it is opposite angle R. So I'm going to have 2x equals 54. Then to get x alone, I want to divide both sides by 2. So then I want to do 54 divided by 2, which gets me 27. Then I want to do the same thing for y. These are opposite parallel sides, so I can go ahead and set them equal. I'm going to have 20 equals 3y minus 1. Then I want to go ahead and add 1 to both sides. Which gets me 21 equals 3y. Then I want to go ahead and divide both sides by 3, which gives me 7. Questions here? We have some other theorems, the parallel consecutive angles theorem. So if I have two angles in a row, so x and y, they add up to 180. Let's try this in blue. So these two will add up to a straight line. And then we also have parallelogram diagonals theorem, which states that if a quadrilateral is a parallelogram, then the diagonals, so the lines from one corner to the other, will bisect each other, which means cuts them in half. So I have QM is congruent to MS, and PM is congruent to RM. So, looking at the ones on the back, it wants me to find, for number 3, the value of M and N. I know M is congruent to the 70 because they are opposite. So I'm going to do the 2M equals 70. And then I want to go ahead and divide both sides by 2. Which gets me 35. Then I can do n plus 70 equals 180. And this is because these two are touching. So I want to subtract 70 on both sides to get n alone. Which gets me 110. Okay, on number 4, I also want to find the value of b. I forgot to ask for that one. So I'm going to start off with these two, since they make a straight line, and I'm going to add them together and set them equal to 180. So then I want to combine like terms. I have two b's, And then I have negative 10 and positive 10, which will cancel out. So I have 2b equals 180. Then I want to go ahead and divide both sides by 2. Which gets me 90. So I can do the opposite ones. I can do C equaling B minus 10, and I know what B is. So I plugged in the 90. 90 minus 10 gives me 80. And then I want to do the same thing for D. So I plug in the 90 for B as well. And then 90 plus 10 gets me 100. Questions on this one? On number 5, it wants me to find the value of k and the value of m. So this one, diagonals, when they're bisected, are congruent. So I'm going to have the k plus 4 and the 11 equaling each other. Then I want to go ahead and solve for k. So I'm going to subtract 4 on both sides. 11 minus 4 will give me 7. Then I want to do the same thing for m. This one is congruent to the 8. I don't have to solve for anything, so m just equals 8. Questions here? So same thing for number 6. I'm going to start off with my u's. This one is equal to this one. So I set them equal. I want to get all of my variables over the same side. So I'm going to subtract 2u on both sides. It'll get me 2 on the left, 3u minus 10 on the right. Then I want to go ahead and add 10 to both sides. So that gets me 12 on the left, 3u on the right. Then to get u alone, I divide both sides by 3, and I get u equals 4. Then I want to go ahead and solve for v. So this is the up and down lines that I'm going to set congruent. I'm going to have 6 equals v over 3. The way I get rid of fractions is multiplying both sides by 3. So that's going to get me 18 on the left and v alone on the right. Questions here? Okay. Number 7, this one's really hard to read. This says x plus 5, and this one says 2x minus 3. So I want to go ahead and set these two equal. Then I want to get all of my variables on the same side. So I'm going to subtract x on both sides. That gets me 5 on the left. 2 minus 1 gets me just regular x, minus 3. Then I want to go ahead and add 3 to both sides, which gets me 8. The last one tells me I have a rectangle QRST. So you always label in a circle. It tells me QS is going to be 6x plus 3. Then it tells me RT is 8x minus 11. So the actual diagonals themselves are congruent. I can set these equal to each other. I'm going to have 8x minus 11 equals 6x plus 3. Then, just like before, I want to get all of my variables over to the same side. So I'm going to subtract 6x on both sides. This gets me 2x on the left minus 11 equals 3. Then I want to get all of my numbers over to the same side, so I want to go ahead and add 11 to both sides. Which will get me 2x equals 14. Divide both sides by 2. I get x equals 7, but if I look back at my original question, it says find the length of each diagonal. This means plug back in x. So I want to do QS was 6x plus 3. So I'm going to plug in my x, which was 7. I can go to Desmos to do 6 times 7. Which gets me 42. Two plus 3 is 45. Then I can do the same thing for RT. This one is 8x minus 11, so I'm going to do 8 times 7 minus 11. I can go to Desmos to do 8 times 7, which gives me 56. Then I want to do 56 minus 11, which gives me 45. So notice both of my diagonals were the same. They should always be the same. Questions here.